In the last video, we talked about inheritance. How can a class inherit the features of another class, like methods and attributes? I will leave a link in the description if you need to refresh your memory on this topic. Today we will introduce the concept of polymorphism. Polymorphism in object-oriented programming means that an object can have many forms. Actually, poly means many and morph means form. This is where the concept that an object can have many forms comes from. In Python, we can implement polymorphism in 4 ways: duck typing, operator overloading, method overloading, and method overriding. Today we will cover duck typing. There's a funny saying that goes like this: if it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck. Let's see how this saying can be implemented in Python. In programming languages like Java and C++, we have a term called static typing. This means that the type of the variable should be mentioned by the developer. However, Python is dynamically typed. That means the type of the variable is determined during runtime. So let's say on line 3 I'll write var equal to 5. So var stores a random number or integer like 5, okay? First of all, var is just a reference to a place inside the memory that stores the number 5. However, because Python is dynamically typed, the variable var doesn't have a fixed type. So right now on line 6 I could say var equal to, let's say, 3.415. And so var right now stores a floating point number, a decimal number. So now var is pointing to a place inside the memory that stores the decimal number 3.15. But it didn't delete 5 from the memory. It's still there, but this time var is just pointing to this decimal number. So right now we know that this var variable is not static. It doesn't have a determined type, or it doesn't have a fixed type. So it changes depending on the behavior. In duck typing, you don't look at the type of the object. If it supports the methods and properties of this class, then it is considered as if it is an instance of this class. Let us see how we can implement this. So I'll create a class called phone. And inside this phone class, I'll create a method called charge battery, because you need to charge the battery of your phone. So I'll print simply a simple print statement, and it will be charging your phone. Okay, now let me create a object of this phone. So I'll say my phone equal to phone, and this is the object of my phone. And of course, to call a method of a object, or excuse me, a class, all you need to do is say my phone or the object dot method name charge battery. If I launch my code, as you can see, charging your phone. Okay, now let me delete this line and create another class, and this class will be laptop. Okay, and this class will have a method called charge battery also, and instead I will say print charging your laptop. Now let's go down there and create a my laptop object equal to laptop. Okay, and this is the object laptop. And of course, if you want to access the method right now, all you need to do is say myLaptop.ChargeBattery. Now I'll create another class, a third class called, let's call it Tesla. And it will have a method called chargeBattery, and you need to charge your Tesla car. So what I will say, print charging your Tesla. Now let me go down there and create a Tesla object. So my Tesla equal to Tesla. Okay. Now we have 3 different classes. They have the same method called charge battery, and we have 3 objects right here of different type. So one is phone, one is laptop, and one is a Tesla. Now I'll create a function, not a method, a simple Python function. I'll say def charge, okay, and it will take its parameter an electronic device or object. Let's say it's better than device. So electronic object. What this does is it will say electronic object dot charge battery, and we know that charge battery is actually the method inside these 3 classes. Now what if I say right now charge, and I mention for the parameter I mention my phone as argument. Now let me copy this and actually paste it 3 times. Instead of my phone, I'll say here my Tesla, and inside my phone here I'll say my laptop, and let's actually launch the code. As you can see, charging your phone, laptop, and Tesla. Now let me ask you a question. What is the type of the electronic object? This parameter electronic object, can you tell me what is its type? Well, we don't actually know. It's dynamic. You can see it was once phone, then it was laptop, then it was Tesla. So it doesn't have a fixed type. So how this works? Those objects are of different type. Well, look closely. These classes, all of these three classes, have the same method, well, in my case, called charge battery. So you can switch or change the type of this parameter from phone to laptop to Tesla under one condition, that all of these types have the same method, which is in my case charge battery. And this is actually duck typing. No matter what is the object, if it looks like a duck, acts like a duck, and speaks like a duck, you'll consider it a duck. Here, in my case, no matter what is the type of electronic object, once it was phone, then laptop, then Tesla, it doesn't actually matter. What matters is how it behaves. Here we are charging the battery of the object, so the object type is determined by its behavior, and this is an example of duck typing. To achieve or implement polymorphism, you can use duck typing, but there's 3 more ways, and we will see them in future videos. For now, I need you to subscribe and follow me in this Python object-oriented programming journey to be able to learn the concepts of OOP in Python. Now I invite you to watch one of these end screens that will appear in front of you, and I hope to see you in the next one.